A man-in-the-middle attack is a cyber attack where an attacker relays a possible or alters the communication between two parties who believe that they are communicating directly. This allows the attacker to relay communication, listen in, and even modify what each party is saying. So, man-in-the-middle attacks enable eavesdropping between people, clients, and servers. This can include HTTPS connection to the websites, other SSL or TLS connection, Wi-Fi network connection, and more. One of the things the SSL or TLS industry fails host is that attacking the viability of the threat poses in the man-in-the-middle attack. And I know this because I have seen it in the first hand and possibly even contribute to the problem. Obviously, you know that man-in-the-middle attack occurs when a third party places itself in the middle of the connection so that it can easily understood, but it's usually presented in the simplest iteration possible, usually in the context of a public Wi-Fi network. So there's a lot more to the man-in-the-middle attack, including just how easy it is to actually pull it off. So today we're going to unmask the man-in-the-middle. So we are gonna demonstrate the attack. So let's just watch how this works. So in this demonstration, we'll use VIF, browser exploitation framework, an open source pen testing tool. It is somewhat similar to the Metasploit. In that it is a modular exploit framework but for the browsers. So VIF hooks on the browser, for instance enabling advertise to launch the expense set of command module inside a browser security context. In addition, it boasts a graphical user interface that streamlines the attack process significantly. So this server runs on a Linux machine, but clients are not really OS dependent. That's because VIF relies on JavaScript code injection as its initial hook. So first step is initial step. So first, VIF server should be initiated on the attack machine. No additional parameters are mandatory. So the framework's web UI is not available, and as you can see in the marked section, and this is highlighted. This location of the malicious JavaScript code is also included. So here is a UI of the authenticated page. So this is the UI of the authenticated page. So after logging in this page, you will see this page. So the second step is hooking. So now that the server side is up and running, and we will need to hook our victim browser by injecting the malicious JavaScript code. Several attack vectors can be used to inject this code, amongst which are MITM, man-in-the-middle attack, reflected or stored accesses execution, and social engineering. But as JavaScript injection is a complex topic and keep this demonstration focused, we will be using a VIF's basic demo page that is already injected with the malicious code. So here you can see that our victim accessing the demo page on his Windows machine through Microsoft Edge, and over to the server side, as you can see in this page, a new client is shown. Now that browser is hooked so that we can use VIF's simple interface and comprehensive list of modules to exploit our victim. So third step is fingerprinting and persistence. So alongside the basic data shown on the hook browser main page, many modules are available like fingerprint the victim and establish the persistence. So among which are, one of them is fingerprint local network, which discover LAN device based on default logo instead of a icon for known network devices and applications. IP range or target port can be customized. Fingerprint browser and fingerprint browsers are capability using fingerprint JS2. Tries detective antivirus, which tries to discern the install antivirus by detecting JS code that is automatically included by some of them, and may detect Kaspersky, Avira, Avast, or Norton and others like certain antivirus. And another last part is ensure the beeps hooks will persist until the victims manually change the URL in the URL bar. Originally, the hook is injected into a single web page, so switching web page will terminate the attack. Beef handles this by listening for the link clicks and handling the request instead of letting the browser to handle it. Sometimes server policies will prevent this behavior if the link is a different domain. So these cases the link will be open to a new tab to avoid losing the original hook. So this is the fingerprint browser command module, and with its result will be shown in the right side. Okay, let me okay. So this is the command module, and as you can see on the right side, this is the result, and this is the detect antivirus command module, and its result showed in the right side. So the step 4 is data collection. After assuming persistence and fingerprinting the victim, adversaries may start to collect personal victim data with the following module. Social detective, detect social network, which detects if the hook browser is currently authenticated or to Gmail, Facebook or Twitter, and Spider Eye, which captures a snapshot of the hooked web pages, as you can see in here, Spider Eye. And another one is get from values, which is retrieve the name, type and value to all input fields. So in this Spider Eye module, as you can see, the victim whose browser tabs are marked as red. As you can see, this is the browser tab, and in this picture it shows it detects social network. As you can see in here, social network. This command module with its description in here and parameters, description parameters are both on the right side. So the fifth part or step is data manipulation. Let me be okay. So adversaries may exploit man in the browser attack to forge request on behalf of the victim, the security context of the hook browser. The victim does all the heavy lifting by authenticating to a certain service, say an enterprise cloud storage, and the attacker swoops at the last moment, sending a request to the storage server to delete all the files. So this is accomplished by the tunneling of the attack desire requested the hook browser session over Beef's communication channel, thus mimicking a reverse HTTP proxy and the hook browser session in the proxy's exit point. So first, the desired hook session must be set as you can see, as proxy server. Now request can be forced through the control interface under, as you can see here, under proxy to force the request. Alternatively, a different web browser can be set to use the proxy server, allowing the attacker to visually hijack the victim's browser. To demonstrate this, we set up a dummy website with a simple login page. So here is the victim machine. As you can see in this picture, victim machine is logging to a secure service. So on the VIF browser, we set up a proxy as shown previously, this one, and configured the Firefox to use it. Now when we access the DVWA website, as you can see DVWA website, we are not prompted with this login screen because we are browsing this in the victim's security context. So this means that the attacker access the secure service without authentication using the hook browser as a proxy access point. So this is all how you demonstrate or how you manage the malware attack in an advanced way using VIF software.